Alright, so welcome to the last section in chapter 3, completing the square. The whole goal in this section is to go from standard form to vertex form. There are a lot of reasons for wanting to do this. For our purposes, graphing would be one reason that we would like to do this. Standard form, it requires some memorization for the X vertex. Also, some people would just prefer vertex form because of all the information it gives you, when it comes to transformations as well, which is something we didn't talk too much about. When you get to calculus and when you study something called differential equations, going from standard form to vertex form can be very useful as well. Okay, so it's a very good, very, very important tool to have in your toolbox. Here we go. The whole goal is completing the square, going from, as I said, this form to vertex form. So it's compared the two forms. Here's standard form at the top. Okay, right here. The advantage is you get the y-intercept by inspection. Okay, it's also a very great form for in calculus when you do differentiation and integration. It's a pretty nice form. Vertex form, the advantage is you get the vertex by inspection, and therefore it's very easy to sketch the graph. It almost comes immediately. So let's go from here to here. Go in the opposite direction is something I did not quite specify, but it's very easy. Right here you just distribute. Right, you would basically work this out to be a trinomial, then you distribute A, and then you would collect like terms, and you're going to be left in your standard form. To go the opposite direction, we have to complete the square. So what does this mean? Completing the square is the idea you're going to try to create a perfect square trinomial. Let's look at this question first before we get into the process. Say you're given y equals x squared minus 8 plus 5. To convert this to vertex form, you can see down here, what you're going to do is the following. You're going to group these first two terms with brackets. You're then going to try to create a trinomial, a perfect square trinomial, by doing a very, very clever procedure. This procedure right here is equal to 0. It does nothing. 16 minus 16. This is a totally legal procedure. But this is a very nice way of rearranging questions, okay, by adding something and subtracting it off somewhere else. So you're going to go 16 minus 16. You get 16, and this is what you're going to have to remember by taking half of the coefficient or the constant value in front of x, which is 4, and squaring it, which comes to 16. You then group the trinomial together. This is always going to be a perfect trinomial just because how you generated the c term, the constant term. And when you figure out what this has to be, first of all, it's going to be the square root of 16, and it needs to be negative because we have a negative over here. You have your x coordinate for your vertex. You then just simply simplify the constant value at the end, and you're done. So when we look at the examples, or I would highlight this in your notes, here is the steps. And what I did is I copied and pasted the same example below, but this time you can see all the steps are going to pair up. One thing I forgot to mention is that at the very start, when you make these brackets, you're going to factor out any constant value in front of x squared. Anything. Here it's 1, so we don't have to do anything. Really, we could factor out 1, it doesn't do anything. But say if it was a 2, you'd have to take that out. So I show you some examples. Hopefully they make sense to you. If not, let's work through the practice problems together. So, here we go. Y equals x squared plus 8x minus 7. That's the first one. Let us complete the square. I'm going to place brackets around the first two terms. Step 2 is I'm going to look at this x term. It has 8 in front of it. what I'm going to do is I'm going to add and subtract half of that squared. 8 divided by 2 equals 4. 4 squared equals 16. Therefore, I'm going to add 16 and minus 16. Okay, minus 7. You're basically going to move this bracket, right, that I just put over here. And we can do that right off the start. Okay. So now you have a trinomial here, right? Let's write that in. Let's write this in. This is a perfect square trinomial. Therefore, you can go right away into what it's going to come out to be. Both terms are positive, therefore it's going to be x plus 4 squared, right? You're taking the square root of 16. You simplify this, and that gives you negative 25. There it is. Oop. That is the answer. That is vertex form. If you want to check it, you can FOIL it out, or you can distribute out. X plus 4 will give you this right here, and then you're going to simply go minus 25 plus 16 will give you negative 7. You're going to get right back to the question. Okay? Let's move on to B. Y equals 2x squared minus 20. You can see A, B, and C all have something different. A, your coefficient in front of x squared, the parameter A is 1, then parameter A is 2 for B, and then parameter A is negative 3 for C. So I'm going to cover all the bases here. The first step is you're going to pair up the first two terms. There are only two terms here, but you're going to factor out 2. Okay. Don't worry about, you just have plus 0 at the end here. It's not written. It's still, you know, there's, you're just at a different point on the graph. The y-intercept here is just 0. So don't worry about it. Procedure doesn't change. That's what we should have. You now do the exact same thing. Half of 10 is 5, squared is 25, so x squared minus 10x plus 25, let's close that bracket, minus 25. You always split up what you added and subtracted. Now what you're given is the following. Now actually there's something very cheeky about this, something very clever, is that this 2 must go to the 25 over here, has to, because what I actually added here was 50 because this 2 is going to the 25. So if I had it outside the brackets, I would be adding 50 and subtracting 25. Therefore, I'm changing the equation, which is incorrect. So you need to keep in square brackets. Okay? Now let's keep going. We have 2, and then we have square root of 5 is, square root of 25 is 5. We have a negative in front of negative 10, so it's going to be x minus 5. You can check that, squared, minus 25. To simplify, you're going to FOIL in 2. So you're going to have y equals 2x minus 5 squared minus 50. Okay. Again, you can check that out with the original. You can graph of technology after this video or during this video to see if we're doing things right here. Okay, part C. Y equals negative 3x squared minus 18 minus 24. Same as before, you're going to factor out negative 3 here, which will give you x squared. And negative 3 out of 18 will give you plus 6x. And then you have a minus 24. Okay? So, let's keep going. We're going to have square brackets. You're going to have x squared plus 6x. Half of 6 is 3, squared is 9, plus 9, minus 9, close the square brackets, minus 24. Remember that negative 3 is going to the 9 inside the square brackets. Now here we go. This is going to come out to be, everything's positive, so it has to be plus 3. That's the square root of 9, right? Squared. And we just rewrite everything. Now we're going to distribute negative 3 to negative 9 here and to x plus 3 squared to give you y equals negative 3 x plus 3 squared plus 27 minus 24. All you have to do at this point is simplify the constant value at the end. And when you do that, let me just erase some stuff here. When you do that, you're left with y equals negative 3 x plus 3 all squared. 27 minus 4 is plus 3. And that's that. Okay? That's pretty much the whole section, completing the square. The next question is just going to take it one step further. You have to graph it. Okay? And not only that, I'm going to throw something else at you here. Basically, completing the square when things are more difficult. And here, things were fortunate. Things worked out well, which is actually not very common. In general, if you just work this in applied problems, this would not happen often. But for instance, negative 3 is a factor of negative 18, so you're not going to be left with a fraction. What if you're left with a fraction, for instance? What if this is a 17 instead of an 18? What do? And you're going to have a fraction, and you can see the work here, but no big deal. No big deal at all. Let's do a question like that. Convert the function y equals negative 3x squared minus 8 plus 13 to vertex form, then sketch a graph of it. So here is the whole story, full story. Step 1, factor out negative 3. Negative 3 is not a factor of 8. So therefore, when you factor out negative 3, you're going to be left with this fraction. Basically, if it's not a factor of the integer that you're dealing with here, negative 8, you're simply going to write 3 on the bottom. Because go backwards now. Negative 3 multiplied by 8 over 3 gives you negative 8. Okay, because 3 is canceling, you're left with that negative 1 out front. Okay, that's step 1. So now you have a fraction, but no big deal, because 8 over 3, half of that is going to be 8 over 6, which reduces down to 4 over 3. Right, maybe I'll write it up here. 8 over 3, oh gosh, let's do it over here. 8 over 3 divided by 2 is equal to 8 over 6, which reduces down to 4 over 3. So 4 over 3 squared is simply 16 over 9. So what you're doing is you're going to go 8 over 3x plus 16 over 9. Close that. And then you're going to go minus 16 over 9, which will give you some square brackets. Okay. And then of course you have plus 13. And you keep going just like before. So don't worry about those fractions. They'll take care of themselves. The square root of 16 is 4. Square root of 9 is 3. So you're going to have x, and everything's positive, plus 4 over 3 squared minus 16 over 9 plus 13. So y is going to be equal, and we're going to distribute negative 3 in now. So we're going to get negative 3x plus 4 over 3 squared. Now negative 3 times by 16 over negative 9 will come out to be 16 over 3 actually. You can do this with a calculator, or you can just figure this out and getting a common, you're just going negative 3 times 16 divided by 9 reduces down to 16 over 3 plus 13. Now, like before, we're going to collect like terms here, or we're going to simplify. So we have negative 3 x plus 4 over 3 and 16 over 3 plus 13 will come out to be 55 over 3. We're just adding fractions. If you don't have a calculator that does this for you, you're going to have to go 13 times 3 to get a common denominator, which is 39 over 3, and that comes to be 55 over 3. So that is the answer. Looks ugly, but hey, that's what happens. Not everything's pretty, right? Most things aren't pretty, actually. Most things aren't, right? Because of the real numbers is continuous line, so you're just going to be getting. It's very difficult to actually land on whole numbers and integers. Now we have to graph this, so we have the vertex right away, right? That's the whole point of doing this, really, right? We have the vertex, which is negative 4 over 3. Be careful here. Remember, in standard form, in vertex form, we have x minus p. So if this is positive, therefore p is negative. And then your y-intercept, or your y-coordinate, is 55 over 3. I'm going to convert this right away to decimals, which will be much more simple, much simpler to graph. I'll take it to 1 decimal place, since it's a sketch anyways, right? It's a sketch anyways. Now we need one additional point before we graph. We do need one additional point close to the vertex, preferably. It could be anywhere, but if we chose the point, say, x equals 0. Now, I did this for a reason. If you choose x equals 0, you can plug this back into vertex form if you want, and you can work out what that happens to be. Let's do this just for an exercise. 0 in for x means you're going to have 4 over 3 squared plus 55 over 3. Now, something's funny that's going to happen here. 4 over 3 squared comes to be 16 over 9 times negative 3 plus 55 over 3 comes up to be 13. Kind of annoying to plug into vertex form, but why don't just plug into your original question? See, if you put in 0, that kills off this term, and you're left with your y-intercept. In other words, just use the y-intercept is basically what I'm saying here. Remember, that's what you do when you have x equals 0. So y-int equals 13. So when you graph this guy, to finish off this chapter, when you graph them, the vertex is just above here, 18, so say we go up by, I don't know, 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, then what are we left with? We're left with the vertex being right here, roughly. The y-intercept is at 13, 2, 4, 6, 8, 10, 12, that's 14, so there's the y-intercept. Hey, stop that. This thing struggles at doing that. Remember the that's where the axis of symmetry is. Therefore, we're just going to simply sketch it on the other side, and we are left with the following graph. And so that's it. So take a look at the practice problems, work hard, and ask me if you have any questions.